Hello, welcome back to Learn Oikonomia. In this video, we are going to discuss a very important topic that is differential calculus. So, this video would be dedicated to the meaning, rules and applications of differential calculus. We'll be understanding the meaning of differential calculus, the rules involved in differential calculus and applications of differential calculus in this video. So, let's get started. What differential calculus is a question we need to understand. We have to answer this question. So this is something which is used as a tool to deal with the rate of change of one quantity with respect to the other quantity. Okay, so we are comparing two quantities and we are going to see how the rate of change in one variable is influencing the other variable. Or you can consider it as a study of rates of change in quantities. If you're taking some examples, you will be able to understand the concept easily. So we can take the examples of velocity and direction. Just compare these two things or just understand how the change in one variable is causing change in other. So one is a dependent variable and other one is the independent variable. Here we are going to look into the velocity with respect to direction. So we are going to see velocity with respect to direction. So here we are considering by definition we can see that if f of x is a function of f dash x or just see that if f of x is a simple function, okay, then f dash x is considered to be dy by dx. So this is considered to be a differential equation where f dash x is considered to be the derivative of the function. And as we have told earlier, here we have two different variables. One is the independent variable and other one is a dependent variable. Here y is the dependent variable and x is an independent variable. So that we can write as f dash x is equal to dy by dx, where we have to understand that x is not equal to 0. What are the basics of differential calculus? This is something which we need to understand. We have already discussed that differentiation is a process where we could find the derivative of a function. So, what are the terms involved in differential calculus? So, what are the terms we have to understand, or what are the conceptual terms we have to understand when we deal with the differential calculus? First one is function. We need to understand the meaning of function. A function is actually a relation from a set of inputs to a set of outputs. So it is a function, it's a relationship between inputs and outputs. Here input is exactly associated with output. So here this could be represented by f of x. Okay. And coming to the dependent variable, we can see that this is a variable whose value always depends on some other variable, or the value of the dependent variable is something which could be determined by using some other variable. And what is this some other variable? This is known as the independent variable. The dependent variable is also known by some other names. Outcome variable is one of the other names which we could use to identify dependent variable, and the result is something which could be evaluated from the mathematical expression using an independent variable. And so this is how dependent variable is functioning. Having discussed the meaning of dependent variable, let's understand the other side of the coin, that is the independent variable. Independent variables are variables which can rely as it is. It is actually not depending on any other terms. It can stand as it is. So these are inputs to the functions that define the quantity which is being manipulated in an experiment. So if you consider the example y is equal to 3x, here we have to understand that x is something which is independent. It is not dependent on y, whereas the case of y is a variable which will change its values, which will change its values depending upon the value of x. So here y is an independent variable and x is a dependent variable. Now let's understand the meaning of domain and range. The domain of a function is defined as input values of a function, and range is the output value of a function. Okay, if you are taking the example f of x is equal to 3x, so this is a function, right? So in this case we can see that the domain value or the input values are 1, 2 and 3. And then the range of a function is given as f of 2 is equal to 3 into 2 is equal to 6. F of 1 is equal to 3 into 1. F of 3 is equal to 3 into 3. So that is how we could find the values. Then understand what limit is. Limit is an important thing, or this is an important concept, especially when we deal with calculus. Limits actually define the continuity of a particular function. Coming to the next term, interval. An interval is defined as a range of numbers. So the number that you have in the question lie between two different numbers. So these two different numbers is known as a range. Now, let's understand the very topic of this particular video, derivative. This is a fundamental tool which is used in differential calculus, and this is used to show how the rate of change happens. This is something which is used to show the amount by which a function is changing for a given point. So we can see that derivative is represented as slope. So it measures the steepness of a graph or a function. It defines the ratio of change in the value of a function to change in the independent variable. This is represented as dy by dx. We need to understand that in differential calculus we use several formulas. So here we need to understand how different formulas are used in differential calculus. We can see different formulas. If you are looking into f of x of dy by dx, here we can understand that dy by dx by dt is not is equal to 0. Let's understand the different formulas used in differential calculus. D of x by dx, that is 1. D of ax by dx is equal to a, which is a constant. D of x raised to n by dx is equal to n x raised to n minus 1. D of cos x by dx is equal to minus sin x. D of sin x by dx is equal to cos x. D of tan x by dx is equal to sec square x. D of cot x by dx is equal to minus cosec square x. D of sec x by dx is equal to sec x into tan x. D of d of cot x by dx is equal to minus cosec square x. D of sec x by dx is equal to sec x into tan x. D of cosec x by dx is equal to minus cosec x into cot x. D of in x by dx is equal to 1 by x. D of e raised to x by dx is equal to e raised to x. D of a raised to x by dx is equal to log of a into ax. D of sine raised to minus 1 x by dx is equal to 1 by root of 1 minus x square. D of tan raised to 1 x by dx is equal to 1 by 1 plus x square. D of sec raised to minus 1 x by dx is equal to 1 by x into root of x square minus 1. So these are the important formulas of differential calculus. Having discussed the formulas of differential calculus, let's understand the applications of differential calculus. Differential calculus is used in diverse spheres in the analysis of different disciplines. So this is not only a term, or this is not only a tool that is used in mathematics. It has been used in many other disciplines as well. We can see that derivative or differential calculus is used to find the rate of change of a quantity with respect to other. That is the rate of change in one variable with respect to the other variable. In case of finding a function is increasing or decreasing in a graph, in order to find the same, we can use differential calculus. Now, it is also used to find the maximum and minimum value of a curve. Since it is something to do with limits, continuity, interval, and all, we can use the concept to find out the maximum as well as minimum value of a curve. Now, it is also used to find the appropriate value of a small change in the quantity. We have seen that it is used as to understand the rate of change in one variable as a result of changes in the other variable. So since it is used in that manner, we can use the same, or you can use the concept, or we can use this to find the appropriate value of a small change in a quantity as well. In real life, also we can use differential calculus in order to deal with the calculation of profit and loss with respect to business and all. And also this is used to calculate the rate of change in temperature. We can also use this to deal with calculation of speed or distance covered, and also we can use this to derive equations in physics. With respect to solutions to differentiation, we can understand this concept by using two examples. The first example here, the question is f of x is equal to 3x square minus 2x plus 1. We need to understand the solution by using the equations. We know that the f of x, 3x squared minus 2x plus 1, that is a question. We have to differentiate both sides. We can understand that f of x is equal to 6x minus 2, where f of x is a derivative of f dash x is a derivative of f of x. Here three, okay. Next, second example, if f of x equal to x cube, where you need to understand how it could be differentiated. The right answer is f dash x is equal to 3 to 3 minus 1. That is here the right answer is f dash x is equal to 3 into 2. Just use a formula here. Okay, so that's all for today. Please like, share and subscribe to this channel for more videos, and you can be a part of my Telegram group and Telegram channel to discuss your doubts. I'll be providing the links of the same in the description box. That's all. Thank you.